Hello, Selwyn. This is Fred from Camplex. I just put together a video of that project we did. I don't think it came out as structured as it would like to be, so I'll redone one so you can see better see how I actually program a part like this. So what you do first, first you read in your model and your step file you sent me, and this is the project data you can do. You can change where you post processor, where your toolpaths go, and so on. They can all be changed later on. So that's the model. So you and what I want to do now is I want to start the machining from the other side. So in the left window here is all your data. So we got like surfaces, and there will be, as we move along, we will have toolpaths and other things in there, boundaries, etc. So this is when you do some operations on a file, on some data, you select the data, and then you apply what you want to do to it. In this case, you want to rotate the model around the y-axis 180 degrees. So you rotate 180 degrees around the y-axis, and say press OK. So as you can see, we're getting another a new model. LCG cam doesn't delete anything, it just creates a copy, and you can always go back to the previous one, but we will not need the initial model anymore. So we select that one, and it's a bit, the set height is a bit high. I want to keep it at top of the part, so we do another transform, and this time we do translate, and it comes out of this box. You can place the datum up at the top or the bottom or on the side or whatever, or a corner of the block data. So you want to place it, the sets here at the top of the part, and we'll say, and it creates a new model again. So I'll delete the first one. So now we got the one we want to use. So a good practice, I think, is to just name the data something meaningful to you. I call it part surfaces here. So and the first thing I was going to do, which you had a little bit of fiddling around with last time, is to do the thread. So we want the thread, because the tricky with this is they're at an angle, so you want to establish the plane where you're going to produce the thread. So what I going to do, I select the part surface, and then I hit.
What is that green thing?
So I select the part surfaces, select that one. So now that's aligned with the plane up here on top is aligned with the screen. And what I want to do now, I want to create a surface on top of that. So I select this surface here, and what I was going to extract the curves of that to produce the surface. I was going to create a plane. So extract the curves from that blue surface, and so I was going to delete. I only want this in a half circle, so I select that, and this one here, and just delete that. So when I got that, so what I was going to do now is going to create a plane inside that curve. So you just you go into geometry, make a planar patch, and this curve is at the bottom of the thread. The top of the thread is 2.5 Z, so it's offset that plane. So now we got that. What we need now to create a thread, we need a center point. Create a center point for. We will create a feature for. You create a feature for if you want to do drilling. In this case, we want to do threading. We want to have a point at the center of the thread. So what we're going to do? So we're going to create and when we want to create some points, so we need to put the points in somewhere. So we create a points folder. So the points will end up here. So I select that surface and the points point folder, and that's where I want to put them. And I was going to create a 3-point arc and put a point at the center of that arc. So I click here. So you get a point there, and then I want to need to proceed, because I was going to use the view for the drilling hole. So I'm going to bring back the top view there. So I press N. Sorry, so here. You see here. You see here. Let's set that there. So now we got the just had to have that surface selected only. So that's the thread plane. So now it's in the position new. So we can do let's see here. Select the points, and I say create a drilling data folder. So create a new folder for the, and then this feature, we create a feature we use for the thread. It will be the same feature if this could be a hole instead. So you may want this feature maybe used to a hole. In this case, we're going to use it for a thread. So the depth is 2.5, and it's going to use this current view rotation for the direction of the feature, and say OK. So now we've got a feature here like that. And then we can create a thread milling. And so we're just going to use a 3mm cutter, a small cutter, and that's pretty much it. Then we're going to go into define the cycle, how we want to use, what we're going to do here. So most of the data here is actually correct. We already defined that. It's in the drilling data. So depth and the diameter. and what you need to do is the pitch is too small, way too small. It's 0.7 it should be, and then you can do in internal or external. So this is external or internal. So we're going to use external, and that's it. So now it's quite quick. So that's created that feature, and we say put in the part surfaces here. You can see that surface is right on top of there, and we can now we want to link the thread part cycle, so we create a entry retract, and then now we can do say okay, so if so that feature is now we can actually copy this, because it's the identical on the other ones. So you can select that one, and you can use edit transform, and you can say we're going to make 2 copies of that one and rotate it on to the other positions. So we rotate that angle, and it's 120 degrees between it, and the rotator on this z-axis, and that's it. So yeah, so we got this threading on this thing out. So that's over and done with, and now it's going to cut the inside. So we can turn those things off, and the drilling data, turn that off as well. That one we don't need anymore. So that's the point. So now it's going to use the part surfaces, and it's going to do first we will want to have like a block, so where we how far out the cutter is going to go. So I was going to create a boundary box. So a boundary box is a rectangular box, which I think is not so suitable here. You can a lot of times a silhouette boundary, which creates a silhouette around the part. So you can select that. So what it does, it actually, so you see, we create the boundaries. So I press Z, look it from the top. Let's see. We want to probably we want the cutter to go outside here, so we're just going to offset it out, say 7 mil outwards. So now we got a boundary we can do all our machining. So that's we're just going to do first. We're going to select the surfaces and the boundary. So now I can either go up here and do passes, or I can do right mouse click, which I do a lot. So you're just going to do, these are all the different machining operations you can do. So we say core roughing process, and I was going to use a cutter that's 10 with a 1 mil radius, and this is the length, and then we put in the passes. We want to leave 0.5 mil on, tolerance is fine for that. And maybe we just do step down, say 0.8 mil, and use the adaptive step down. So we'll introduce some extra passes if we can fit them in to maintain that 0.8 step down. So then we'll allow it to go to -7, and so then it creates the this is the roughing program. So so we create the passes to make it like a toolpath. You need to link the passes. So now we can do so. Let's see what it. So that's so. The next thing is we're going to do a rest roughing here, but we might do a stock model of this. One of the big benefits with the LCG cam, it calculates stock models very fast. I mean, it won't really show up on this part because it's a very small part, but if you have a very large part, it still calculates like complex stock models very quickly. So I selected the boundaries and the toolpath, so we'll actually use the boundary as the block, and then we apply the toolpath onto that block, so in which case then the stock model. And let's say I just use 0.25. It's enough. So you can if you so that's the toolpath. So that's what it looks like after you run the toolpath. Okay, so now we want to I was going to do a smaller cutter to get in more in the corners and things. So you do a bit of rest roughing. So select the boundary, the roughing toolpath, the previous one, and I say rest roughing. And here I'm going to use a 4 mil end mill. That's probably right. And we select the passes. We leave 0.5 mil on. If you put 0 in here, that they will sort of cut everywhere. And step down is probably the 4 mil. So let's say more 0.4. And we will still do the 7 mil depth. And that should so. Let's see here. So it goes into all these corners. So we link that toolpath together. This linking, there's a lot of different options. You can link it in different ways. You can link it by a level, or it's a lot of other options. So, but basically the default works well for most cases. So we do create a so you can So that cuts out a bit more material. So if we create a new stock model, say the boundaries and call that. Another stock model 0.25. So what you can see now is it's nearly done. There's probably a bit more in these corners that's going to be dug out, and we need to do another roughing in this to cover up this area with a smaller cutter. So we use a 3mm end mill for that. And we need that 0.5 on, and step down should be probably very small. It should be 0.3 possibly. And keep that as -7. And that should do about that. So that just cleans out those corners there a little bit more, and we just do link those. So what we can do now, we can actually try to put I was going to cut, finish off all the flat areas. So you can, I'll just turn this toolpath off, and we just go in here and do horizontal area passes. And we use an 8mm cutter flap end there. That. And you see passes. We leave 0 material on. And so the scale, the tolerance, offset. So make me put that 7 as well. So if I do link that together, I can see how it's going to do that. So and then we do finishing, or sort of waterline finishing toolpath to cut all the sort of vertical sides. Waterline passes, and it's going to use a 6mm ball nose. So that's, we leave nothing on. Let's finish it toolpath. Step down, probably 0.6 should be okay. Maybe maybe use 0.5 instead, and 7, and just to what we should do, we should not, I can put in 0.1 there, so it means it won't cut anything on sort of flattish areas. So we say this is what it does here, and that's all okay. We can link that together. Okay, and to get into the smaller areas, because say if we look at the curvatures, you can see this area here. If we take maybe say 5 mil maximum raise, so in here you can see that's 2 mil radius. So, and we cut it with a 6 mil, so we need to go with a 2 mil radius cutter, 4 mil, 4 mil ball should do it. So it take and we go sorry. Rest finishing passes. So we select a 4 mil ball nose. That's all okay. You see here, and the passes we leave 0 on, material on, and step down, say 0.4, and then we use a reference cutter. So that's the previous cutter. It was a 6 mil, but we cheat a bit. We say it's 7 mil, so it means it will over cut a bit more than the 6 mil did. And we say maybe say 7 there, and the this passes in here, we don't need those. So we can delete those because that's already done with the previous cutters. So we just do leave those passes. And be interested to see what that's going to look like now. So yeah, I might just do a stock model for that, or the toolpath we done. Stock model, and I might just do a 0.1 tolerance. So we can see this probably a little bit material left in there. So it's going to do that is the waterline machine. So I use that stock model and I select the part, and I can probably select the boundaries as well, and so the waterline passes, and it will cut between that with the stock model and the CAD model. So it's going to use a flat 0.2 and radius 2.5 mil, and you can see flute there's that should right, so that should be all okay. Process, and we don't leave any material on. Tolerance step down 0.06, and I see what happens here, 7 here. So it should finish up these corners here, okay. You see, it's done it quite well. It's only so I just need those. It seems to be actually what that should be. I should check. Let's take the stock model off because you got some passes here we don't want to run. So I select those. I delete those. So we link those. So that's basically that side should be nearly finished, pretty much finished now. So so we can do this. Select. I do a stock model of that. A 0.1 should be enough. So you see it's cleaned up all that pretty well. Alright, so that's side is pretty much finished now. So what we're going to do, we're going to cut the other side. To do the other side, we will take off the stock model, and I was going to create another boundary from the other side, because basically you use boundaries as like a work plane. So if you want to create, so what I do, I create a custom view, and I use the tool axis to define. So I rotate 180 degrees around the Y, and I say apply that. So you can see, so this is the new view from the bottom, and say OK, and then I select the surface, and I create a new I hit control, and I say select boundaries. If you hit control, it comes up with this menu, so you can apply the boundary to the current view rotation. So this is I So we call it rear, say, boundary. And you got the rotations, the B is minus 180. What I often, it may be easy to look, is I might just rename these toolpaths. I call them A, the top one is A. A. Just to keep them separate, so because we're going to create the bottom toolpath now. Okay. Like that. So now I call these toolpaths from this side, I call them B, start with B, we rename them like B. So I use the rear and the toolpath, part surfaces, and what we do, I want to do this rear boundary, I want to offset it actually, because otherwise it won't go on the outside. See that boundary, that's there. If I offset that one, say 7, it will have the right size, like that. So we use that one, select the part surfaces, and then we do a core roughing of this one. I'll select the same 10 mil, 1 mil radius, passes, leave half a mil on, tolerance, step down 0.3, maybe a bit small, so a bit good, 0.6, and we don't need, so let me leave it like that, that's probably right, and then say adapted step down, so that's the passes, so we say OK. So now we got these passes here, they all look okay, pretty much what we want. So you just link those. And to finish that top surface, I was going to use let's use a spiral machining. So I use select my part surfaces, offset boundaries, and do spiral passes. And this is all open. I can use a reasonably large cut. I can use a 10 mil ball passes. So we spiral down, step over 0.2, get a good finish. So let's say that's what we want. Okay. So it's created a spiral finishing. So if we link those passes, so B, B. So that's pretty much finished that. If we create an offset boundary and the do a, say like a stock model of that, 3.25 probably enough for that. So we'll see. So let's cut that from that side. So pretty much. So that's pretty much concludes our machining. So hope that is a bit clearer to you. If you want to ask anything, please don't hesitate to give me a call. Something I maybe haven't showed you yet. No, actually, this is the post-processing epoxy. We can really, if you want to post-process a program, so you can just say post-process, and there's the things you can change here. You can change the rapid speeds and things and cutting speeds, and it will put it in your Selwyn's folder I've created, and so it's just post-process now. So that's, you can view the tape file. So that's the file you create. This is a FANUC. I've got a feeling you have a FANUC control on your machine. I'm not sure. On your Hoko machine. It could be a hard 9 too, I suppose. And that's quite easy. All the post processors for 3-axis are part of the system. So basically you do, if you have a FANUC control, you start off with a FANUC's standard post, and then there's about 400 different parameters you can change to make it specific for your machine. So hope that all explains it. Hope to talk to you soon. Excellent. Good to hope this helps you understand the NCG can quite a bit better. Thank you.